Hi everyone, I've just done a project recently called AuxyWrap, and this is a little GIF that was made using SolidWorks. So a little overview about what AuxyWrap is that it is a wrap that is auxetic in structure, so that it is able to conform around to different shapes. So for instance, it is able to bend in a direction and allowing it to wrap around the cylinder. It is also able to stretch in both different directions, which in this case is something like this. So it's like it expands simultaneously in both directions and compresses in two directions also. This is to allow it to like increase in the length as well as the width. So in this case, I will be using the flex feature in SolidWorks so that I can make it wrap around a substrate. I mean the contents. But of course, I will not be using AuxyWrap. I will just be using a sheet to actually wrap around, to make it wrap around. Because there are a lot of edges and it will be very hard for processing. So without further ado, so I get this out of the way and I make the background white. So what I'll do, I mean the shape that I will be starting out with is 10 cm by 10 cm 10 cm by 10 cm square. And then I extrude a 1 cm thick so that it looks similar to, how should I say? It is similar to AuxyWrap. Okay, this looks a bit better. So what is important here is to actually a bit of draft. This is a bit of draft here. So you will need a line, a construction line. That's your so-called neutral axis. And then you need another line to show the original position, and after that you need an arc to show the final position of it. And then for the arc, you will need two things, which is the bend angle and the bend radius. So I'll draw a line, I mean a few lines, the bend angle and then the bend radius. These are what we will need for now, and we shall do the dimensions. So I will just put this at 60. Okay, maybe 120. Any number is good here. And then this, in this case, I will be making these two the same length because I want the whole thing to bend. So these dimensions will be 10 cm. Select midpoint. These 2 points, I'll make it vertical. These 2 points, I'll make it vertical. So for this, I will be using the top surface as my so-called neutral axis, although this isn't a good representation of actual bending, but then I'm just going to fit this dimension as the circumference of the product. So these two go curve length. And then after that, I move my things a little. I'll also need the radius. And then make both the bend angle and the bend radius driven. So what you will get is something like this. I will make these two lines collinear, and then these two tangent, so that I can put rest these lines at the top. And then I make these two collinear. Tidy up my sketch a little. And then organize a little bit of the name. This is bend, angle. And then this is bend, radius. Do not worry that this is underdefined sketch lah. Because if you are like fix a specific, how should I say? If you fix a specific, if you fix the angle, it will be sort of defined. Oh yeah, I also need another line to actually give a gauge. So this will be from the center to the edge. And then I will be using this angle later on. I won't be giving the dimensions here, because this will be done in an assembly and then making it parallel to an external object. So I think this is complete. Exit sketch. And then I rename this to make it a little easier to read. So this is the flex graph. Another thing that we will need is the triad. So I select this point and then I'll add a triad. I'll add a coordinate system and then select z-axis to make it, to be at this line. Now select this and then I have my coordinate system. Good practice again to reading. Not sure if I spelled it correctly, but yeah. Now time to do the flex. I don't usually like to select my flex input first because it will make it hard. It will make it hard for me to select my coordinate, my subsequent stuff later. So I will select my first one, trim plane. I select the final points and then I select my triad. And then finally, I'll select my flex input. Like this, it will be easier for me to select. So I will make it a random angle. But then this isn't the right direction I want. So I will put a negative sign in front. And then this is the correct dimension. Okay, now the flex is looking a little better. Double click the flex. And then this is the angle. This is the sort of angle that we will need to change. Double click this, close, open inverted comma, flex, angle, add, flex, draft. I think I spelled something wrongly. Let me take a look. Edit sketch. Double click. Oh, it's bend angle. Okay, so I copy the whole thing. Exit sketch. Go back to flex. Edit feature. Oh, sorry. It's not edit feature. Where is my... Oh, double click this. Double click the 18 degree equals. Open inverted comma. And then select the relations. Enter. Okay. And then rebuild. You will realize that the angle is actually, how should I call it? You will realize that the bending is actually the same as the line that you have drawn. So I will now try with a little more numbers. Maybe I'll make this non-driven first. Yeah. So let's say if I were to put 1 degree, it will be something like this. And then if I were to put 90 degree, 90 degree doesn't look okay. Let's say 89. Does it work? Yeah. 89 looks okay. Weird. So let's say 179. Yeah. So this is 179. Still looking okay. And then 359. Okay, guess I shouldn't try that yet. Oh, yeah. Things will be weird if you go way too much. So okay, so 179 will be our max. And then give it back to driven and then save the file. This will be our rack. Okay, looking good. And then hide this thing and hide the Triad also. Okay, so we will be making a dial next. We do not need very accurate dimensions for this. So it's like just a circle. And then just a center rectangle. Maybe I'll do something like that looks okay. And this is about 30, 40. And then after that, trim entities. Oh, shouldn't be doing this. Trim entities. Keep trim entity as construction lines. Okay, exit sketch, extrude. And then I'm done with this. So this thing also save. This will be my dull. And then I'll make a new assembly out of these two. So I'll put the wrap in first. Make it float. And then I'll fix the origin. No, go away. Okay. Okay. This one delete. and then fix it back. Then I'll put in the die over here. This is a little too big, but oh well, doesn't matter. Origin, make, concentric. Afterwards, select the bottom, select these two, coincident. I think for this line, I'll select something else. So I'll delete this and then redo this. Yeah, concentric to the triad instead. Okay. Now I will want this line. I will want this to have an angle with this this thing. So that will be, let's say, 59 degrees. So just a little check. 59, okay. Maybe I'll put a bit less, 60. This is to sort of see the dimensions. Yep. Okay. So my mating, all the mates are okay. And then I will be going back to edit my sketch to make this line parallel to the line here. So right click, edit sketch, save as, I think of a good name. We save all, and then I make this, I select this line, select the line here. What's going on? Something feels weird. And then now, now all this is fully defined, and then I can sort of select this. Change this accordingly. So maybe I shouldn't be trying 1 degree. Go back. Yeah, undo a little bit. Oh no, I can't. Let's say 15 degrees. How about? Oh, the rebuild work. No. Sad. 60, okay. Let's try 30. 30 looks okay. 15 also okay. 10. Yeah, 10 also okay. I guess this will be our starting point then. So we are going to start at 5. And then jot it down somewhere. I think our maximum was at 89, right? Yeah, 89. So these two numbers we will be using for our what do you call that? Motion analysis later. So I will leave it at 60 first. So later it will be a 60 to 15 to 89 to 60. maybe I should leave this, maybe I should leave all the lines around so that we could see it later. Save all. And then go over to motion study. Why is this so weird? Okay, anyway. So I don't like to use this at the start. This is our camera view, and then the angle, I will be changing this 60. Place key. Place key. Maybe I place something here. And then I will do place key one more. 60 to 60 to 5. So maybe not. Maybe I increase it first. 60 to 89. To 5 to 60. And then I will build the whole thing. And then this will be our whole animation. But of course, a few things that you will want to do is to obviously hide the construction lines, which I didn't, and also hide this down. Viewing this on another angle, so we will get something like we will get something like this. So what are the advantages of this method? This method is like it will allow you to actually like edit the lines based on this draft. Wait, this is annoying. So it's like if let's say I want to change this a little, maybe to 60. It's like so that I can actually make this part bend instead of the whole thing. And then another point to note that this solid need not be a flat plane like this. It could be something like a complicated shape, like the AuxyWrap earlier. So I need to rebuild my component, which is super weird now. I'll change the mate to a little. So it will look something like this. So that's it. Something feels a little wrong here. It should, I mean the whole thing should be parallel. Which in this case it isn't. It looks correct here though. Oh yes, it's correct now. But then if I were to run a motion study over, if I were to run a motion study with this shape, it is going to look weird because this part might intersect. So it's like, yeah, and that's the intersect. And then it opens up. Yeah, and that concludes the whole little review of what I've done for my AuxyWrap video. I mean for the AuxyWrap project. Hope Hope you all enjoyed it. Thank you.